Hello students, welcome to class 12th. As it is being said in the entire world that unprecedented times demand for unprecedented measures. Our college has also come up with this idea of connecting with you digitally as it become the need of the hour. And today I am going to start with a topic which is very relevant nowadays. You must be hearing a lot about the change in the number of patients being infected cured of COVID 19. So, what are these? Do they represent the rate of change of any quantity? Yes, they do. And that is what we are going to study today. Instantaneous rate of change of any quantity is also known as differentiation. So, today we are going to study the first chapter of 12 Science, paper 2, differentiation. Okay, before going to start this chapter, be ready with your pen and notebook so that whatever important thing I am going to tell you, that you all can write it down. Okay, so first of all, we'll revise what we have done in 11th standard. So let's revise. First, we'll revise the definition. The derivative of f of x with respect to x at x equals to a is given by f dash of a equal to limit h tends to 0 f of a plus h minus f of a upon h. Alright, over here I have taken at x equals to a. In next, we'll see the derivative can also be defined for f of x at any point x on the open interval as f dash of x equal to limit h tends to 0 f of x plus h minus f of x upon h. Okay, so in the first equation I have taken at x equals to a. All right, and in the second we have taken at any point x. Fine. Next, if the function is given as y equal to f of x, then its derivative we can write as dy by dx equal to f dash of x. Okay, we can write in this form also. Next, we'll see for a differentiable function y equal to f of x, if delta x is a small increment in x and delta y is small increment in y, then we can write as limit delta x tends to 0 delta y upon delta x equal to dy by dx. So this we will be using further. Okay, next we'll see derivative of some standard functions. This you all have done in 11th standard, but still will revise. Derivative of constant will be 0. Derivative of x raised to n will be n x raised to n minus 1. Derivative of 1 by x will be minus 1 upon x square. Derivative of 1 upon x raised to n is minus n upon x raised to n minus 1. Derivative of root x will be 1 upon 2 root x. Derivative of sin x will be cos x. Derivative of cos x will be minus sin x. Derivative of tan x will be sec square x. Alright. Next, derivative of sec x will be sec x tan x. Derivative of cosec x will be minus cosec x cot x. Derivative of cot x will be minus cosec square x. Derivative of e raised to x will be e raised to x log e. But what is log e? Is 1. So that is why derivative of e raised to x is e raised to x. Derivative of a raised to x is a raised to x log a. Derivative of log x will be 1 upon x. Derivative of log x to the base a will be 1 upon x log a. Students, you can see here when we take the derivative of cos x, cosec x and cot x, in the answer you have to take care that you have to mention negative sign. You can see over here derivative of cos x is what? Minus sin x. Derivative of cosec x is what? Minus cosec x cot x. And derivative of cot x is what? Minus cosec square. So you have to be very careful while writing the derivative of cos x, cosec x and cot x. What you have to remember? You have to put the negative sign over there. Alright, we'll go next. Rules of differentiation. We'll see whether we can apply addition, subtraction, multiplication or division. Let's see. If y, if u and v are differentiable functions of x such that y equal to u plus v or u minus v, we can write as dy by dx equal to du by dx plus dv by dx, or for subtraction we can write dy by dx equal to du by dx minus dv by dx. Okay, so over here we can apply addition and subtraction in derivative. Let's see about multiplication. So if y equal to uv, I'll consider u as first function, v as second function. You can take v as first function and u as second function. There is no problem in that. Okay. So derivative, how we will be writing? Dy by dx is equals to first function derivative of second function plus second function derivative of first function. Like this, we can apply the product rule in derivative. I'll repeat, first function derivative of second function plus second function derivative of first function. Okay. Now we'll see, can we apply division in derivative rule? Yes, we can apply, and this is called as quotient rule. So we'll consider y equal to u by v form, where v is not equals to 0. If v will be 0, then your given function will be not defined. So over here, I'll consider u as numerator and v as denominator, because many students make mistake over here that whether we have to take numerator or denominator, whether we have to take u or v. Okay, so just remember that in the numerator and denominator, so that you will get to know how we can apply quotient rule. Okay, so dy by dx equal to denominator ddx of numerator minus numerator ddx of denominator upon denominator square. Okay, so over here we have seen the rules of differentiation. We'll see next. You can see some functions on screen, right? Sin x, e raised to x, log x. Over here also we have sine of log x, root of tan x and e raised to tan x. Okay, so we can find the derivative of sin x easily. Yes. The derivative of e raised to x. Yes. The derivative of log x. So these are called as simple functions that we can find the derivative very easily. But what about sine of log x? What about root tan x? What about e raised to tan x? So these are called as composite functions. Okay. So today we are going to study composite function. So let's move ahead to class 12th. In this, we are going to cover first the derivatives of composite function theorem and proof, then derivative of some standard composite functions and solution to some examples of composite functions. So let's see the theorem first. If y equal to f of u is differentiable function of u and u equal to g of x is a differentiable function of x such that the composite function y equal to f of g of x is a differentiable function of x, then we can write dy by dx equal to dy by du into du by dx. This is also called as chain rule. Let's see the proof. Given that y equal to f of u and u equal to g of x, we assume that u is not a constant function. Let there be a small increment in the value of x is delta x, and delta u and delta y are corresponding increments in u and y respectively. So as delta x, delta u, delta y are small increments in x, u and y, we can write delta x is not equals to 0, delta u is not equals to 0, and delta y is not equals to 0. So what we can write? Delta y upon delta x equal to delta y upon delta u into delta u by delta x, because delta x, delta y and delta u are the small increments in x, u and y. So taking limits as delta x tends to 0 on both sides, we can write as limit delta x tends to 0, delta y upon delta x equal to limit delta x tends to 0, delta y upon delta u into limit delta x tends to 0, delta u upon delta x. As delta x tends to 0, we get delta u tends to 0. Why? Since u is a continuous function of x. So we can write limit delta x tends to 0, delta y upon delta x equal to limit delta u tends to 0, delta y upon delta u into limit delta x tends to 0, delta u upon delta x. We'll give this equation as 1. Since y is differentiable function of u and u is differentiable function of x, we have limit delta u tends to 0, delta y upon delta u equal to dy by du, and limit delta x tends to 0, delta u by delta x equal to du by dx. We'll give this equation as number 2. From 1 and 2, we get limit delta x tends to 0, delta y upon delta x equal to dy by du into du by dx. We'll give this equation as number 3. The right hand side of 3 exists and is finite, implies the left hand side of 3 is also exist and it's finite. So we can write limit delta x tends to 0, delta y upon delta x equal to dy by dx. So equation 3 becomes dy by dx equal to dy by du into du by dx. We have proved the theorem. So students in board exam, they can ask these type of theorems for 3 marks. So you have to take care that whatever is there in text, the theorem, you have to write as it is. Then only you will get full marks. Okay, don't make any changes over there. Otherwise, you will lose your marks. We'll go further. Derivative of some standard composite functions. The first function is f of x raised to n. Can we relate this? Yes, we can relate this with x raised to n. Okay, so how we can find the derivative? Fx raised to n will be n fx raised to n minus 1, and then again the derivative of f of x. Over here also root of fx will be 1 upon 2 root f of x, then again the derivative of f of x. 1 upon f of x raised to n will be minus n upon f of x raised to n plus 1, and again the derivative of f of x. In the same way, for sine of f of x will be cos of f of x, again the derivative of f of x. Cos of f of x will be minus sine f of x, again the derivative of f of x. Tan of f of x will be sec square f of x, again the derivative of f of x. Cot of f of x will be minus cosec square f of x, again the derivative of f of x. Sec of f of x will be sec of f of x, tan of f of x, again the derivative of f of x. Cosec of f of x will be minus cosec of f of x, cot of f of x, then again the derivative of f of x. Then derivative of a raised to f of x will be a raised to f of x log a, and again the derivative of f of x. E raised to f of x will be e raised to f of x, and again the derivative of f of x. Log of f of x will be 1 upon f of x, and again you have to take the derivative of f of x. And log of f of x to the base a will be 1 upon log a f of x, and again the derivative of f of x. So I think you must have written the formula. Now we'll see some examples. The first example is differentiate with respect to x cos square of log of x square plus 7. Okay, so what we will be doing in this? First of all, we are going to consider y equal to cos square of log of x square plus 7. So over here we have to differentiate with respect to x. We can write as dy by dx equal to ddx of cos square of log of x square plus 7. So over here, first of all, we will be applying the derivative of f of x raised to n, that is n cos of log of x square plus 7, and again the derivative of cos of log of x square plus 7. Okay, in the next step, 2 cos of log of x square plus 7, and the derivative of cos of f of x will be minus sine log of x square plus 7, and again the derivative of log of x square plus 7. Next we'll see 2 cos of log of x square plus 7, then minus of sine of log of x square plus 7, and again we have to take the derivative of log of f of x, that is 1 upon f of x, and the derivative of x square plus 7. And what is the derivative of x square? It's 2x, and derivative of 7 will be 0. So I have written over here 2x. Now in the next step, I have multiplied 2x and 2, so we will be getting minus 4x cos of log of x square plus 7 sine of log of x square plus 7 upon x square plus 7. So see, I have bifurcated minus 4x as minus 2x into 2 of cos of log of x square plus 7 into sine of log of x square plus 7 upon x square plus 7. Why I have done? Because I have the formula of 2 cos theta sine theta. It's what? Sine 2 theta. So I can write this as dy by dx equal to minus 2x sine of 2 log of x square plus 7 upon x square plus 7. So this will be the answer. Okay. So we'll see the next example. The next example is differentiate root of cos x plus root of cos of root x. So first of all, we will be considering y equal to root of cos x plus root of cos of root x. We will be differentiating first. So dy by dx equal to ddx of root of cos x plus root of cos of root x. Over here, I have applied the rule of differentiation. So this will be ddx of root of cos x plus ddx of root of cos of root x. Okay, what is the derivative of root of f of x? It's 1 upon f of x, again the derivative of f of x, plus over here also root of f of x, so 1 upon 2 root cos of root x, and then again the derivative of cos of root x. Then I can write the derivative of cos x will be minus sin x. So I can write this as minus of sin x upon 2 root cos x plus 1 upon 2 root cos x root x, and derivative of cos of root x will be minus sin root x, again the derivative of root x. Then I can write this as minus sin x upon 2 root cos x minus sin root x upon 2 root cos x root x into 1 upon 2 root x. The derivative of root x will be 1 upon 2 root x, and I have written in a proper manner. So dy by dx will be minus sine x upon 2 root cos x minus sine root x upon 4 root x into root cos x root x. So this will be the answer. We'll move ahead. Next example, differentiate log of a raised to cos x upon x square minus 3 whole cube log x. So over here, what we can do? So first of all, we'll consider the given function and we have to apply the log rules. So let's see. Y equal to log of a raised to cos x upon x square minus 3 whole cube log x. So over here I can apply the division rule of logarithm. So I can write this as y equal to log of a raised to cos x minus log of x square minus 3 whole cube into log x. So the division I have written in subtraction and the multiplication I have written as addition over here. So we can write y equal to cos x log a minus 3 log of x square minus 3, and I have opened the brackets over here. This will be minus log of log x. Alright, and whatever we were having in the power, that I have written as a coefficient of log over here. We can write this is also one of the rule of log. So now we can differentiate. So dy by dx will be log a over here is constant. So I can write the derivative of cos x as minus sin x. And over here I can apply the derivative as minus 3 upon derivative of f of x will be what? 1 upon f of x. Again the derivative of f of x. So I have written 3 upon x square minus 3. And again the derivative of x square minus 3. And log x will be minus 1 upon log x, and again the derivative of log x. In the next step, dy by dx equal to minus log a into sin x minus derivative of x square will be what? 2x, and derivative of constant will be 0. So this will be 6x upon x square minus 3 and minus 1 upon x log x. What is the derivative of log x? It's 1 by x. So just I have written in a proper manner over here. So dy by dx will be minus log a sin x minus 6x upon x square minus 3 and minus 1 upon x log x. So this will be the answer. Let's see the last example of today's class. Differentiate with respect to x, y equal to 25 raised to log sec x to the base 5 minus 16 raised to log tan x to the base 4. Okay, so over here we can't apply directly the derivative. So first of all we have to apply the one of the rule of logarithm over here. Okay, so let's see. Y equal to, I have written 25 as 5 square. So 5 square log of sec x to the base 5, and 16 I can write as 4 square. So 4 square log of tan x to the base 4. So I have taken this to the coefficient. So I can write as y equal to 5 raised to 2 log sec x to the base 5 minus 4 raised to 2 log tan x to the base 4. So whatever I have here as 2, I can take as the power. So I can write this as y equal to 5 raised to log of sec square x to the base 5 minus 4 raised to log tan square x to the base 4. So I have written over here the formula as a raised to log x to the base a will be x. So I have written as y equal to x square minus tan square x. Okay, what is x square minus tan square x? It's the basic identity of trigonometry, and the value of x square minus tan x will be 1. So we'll differentiate with respect to x. So the derivative of constant will be 0. So your dy by dx will be 0. So this will be the answer. So I think students, you must have studied, you must have understood how we can apply the composite functions in derivative. All right, so you all can try it out, the examples of exercise 1.1. Okay, now in the next lecture we will be doing geometrical meaning of derivative and derivative of inverse function. Okay, thank you.